It's funny how the universe just constantly finds ways to surprise us.
Oh, absolutely.
You'd think, logically, the first planets we'd find outside our solar system would be orbiting some nice, stable, sun-like star.
That's what everyone is looking for.
But no, the very first confirmed exoplanets, the ones that proved it could be done, were orbiting a stellar corpse, a star that had already died.
Exactly. We're talking about pulsar planets, and a pulsar is, well, it's the remnant of a huge star that went supernova.
So it's the leftovers.
It is, but it's an extremely dense, rapidly spinning leftover, and that spin is key because it's incredibly regular. They're basically the most precise clocks in the known universe.
Okay, so let's talk about that first discovery in 1992. Bolzan and Frail, around PSRB 1257 plus 12. That really changed the game, didn't it?
It proved not only that exoplanets were real and detectable, but that they could exist in the most extreme places imaginable.
Right, and the method they used wasn't what anyone expected. It wasn't about looking for dimming starlight.
Not at all. It's called pulsar timing. Imagine the pulsar as a cosmic lighthouse sweeping a beam of radio waves past us at incredibly precise intervals. We know exactly when that pulse should arrive.
Down to the millisecond.
Even more precise. So if a planet is orbiting it, its gravity causes a tiny tug, a little wobble. That means the pulse arrives a fraction of a second early or late, a Doppler shift in time.
That is just an insane level of precision.
It is. We can detect objects down to the size of a large asteroid with this. In fact, the least massive exoplanet we know of is a pulsar planet. It's only about 2% of Earth's mass.
Wow.
There's almost nowhere to hide from that method.
Which brings up the big logical question for me. A supernova is. It's about the most violent event in the universe.
It is.
So how could any planet possibly survive that? Or how could it form afterward?
That's the core of the mystery. And you're right, they almost certainly aren't survivors. We call those first-generation planets, and they would have been, well, vaporized.
Okay, so they're new.
They're new. The leading theory is that they are third-generation planets. They form after the supernova from a completely new disk of debris.
But where does a dead star get a new planet-forming disk?
By destroying something else. Often the pulsar has a companion star, maybe a white dwarf. The pulsar's intense radiation and gravity literally tear that companion star apart.
Or it rips it to shreds.
Exactly. And that creates this massive cloud of super dense material from the dead star's guts. That material then settles into a disk and starts clumping together to form new worlds.
So you're building planets out of the ashes of another star.
You are, and that's why their composition is so bizarre. You take apart a carbon-rich white dwarf, you get carbon-rich planets.
Which leads to the famous diamond planet.
Precisely. PSRJ 1719 3-bat Fertidae B. It has about the mass of Jupiter, but it's incredibly compact, less than half Jupiter size. That density suggests it's made of crystalline carbon.
A literal diamond planet. The universe has a wild imagination.
And it also shows us resilience. Another one, PSR B620 EOH26b, is thought to be maybe 12.6 billion years old, one of the oldest planets we've ever found, proving this can happen in all sorts of environments.
But they're still incredibly rare, right?
Yeah.
Only a handful have been confirmed.
Very rare. The conditions have to be just right. And then, finding that tiny timing signal in all the cosmic noise is a massive computational challenge.
That process, pulling a clean signal from all that complexity, really highlights the power of advanced computational systems. In fact, this deep dive into complex systems is brought to you by Embersilk. If you need help with AI training, automation, software development, or just figuring out where AI agents can make an impact for you or your business, check them out at embersilk.com.
It's a perfect analogy, actually.
So, stepping back, what does this all mean? These worlds are blasted with radiation. Probably not great for life as we know it.
Probably not, no.
But their existence, just the fact that they're there, seems incredibly optimistic. It shows that planet formation isn't some delicate, fragile thing. It's robust. It just happens.
It truly is a hopeful sign. It shows the universe can restart and rebuild even after a catastrophe like a supernova.
And here's a final thought to leave you with. Based on the few we've found, some astronomers estimate there could be as many as 10 million pulsar planets in the Milky Way alone.
Just waiting to be discovered.
Imagine what else is out there. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.